Let's discuss this question next. The question 11 says find the equation of all lines having slope 2 which are tangents to the curve this y equals 1 upon x minus 3 where x is not equal to 3. Now what should we do in this one? We have slope 2, lines having slope 2 which are tangents to the curve this. So let's begin with this curve y is equal to 1 over x minus 3 and try and find the derivative. Now derivative will be equal to the slope of tangent which is given as 2. So on the basis of that we can easily find the points, right? So dy upon dx is equal to, this is 1 upon something, this is minus 1 upon that something squared, okay. And what about the derivative of x minus 3? The derivative of x minus 3 is simply 1, so we're not supposed to worry too much about anything. This is what you get, right? So minus 1 upon x minus 3 whole square is the derivative. This is equal to the slope of tangent, so let's do that. Therefore minus 1 upon x minus 3 square is equal to 2. And on the basis of this I can find the value of x, that is the point at which the tangent exists, right? Slope is given, I can find the point and then I can find the equation. But do you realize that from here you will get x minus 3 whole square is equal to minus 1 by 2. Tuck tuck, yes. And this is square quantity, this is always greater than equal to 0. This is negative. Oh, a positive, non-negative quantity and negative quantity, can they ever be equal? No, they cannot be equal for any real values of x. So x does not belong to real. There is no real value of x that exists. Therefore, no such tangent exists. That's what you can say. In this particular case, this is a trick question. And yes, in this particular case, no such tangent exists, right? The slope 2 is not okay. Any positive slope will not be okay in this one. Can you also note such a thing graphically? Yes, maybe you can note this thing graphically. Y is equal to 1 upon x minus 3. The graph would look something like this. The line x equal to 3 will be an important line, x equal to 3. This is an important line, right? For x equal to 3, the function is not defined, right? So this line is a dotted line, okay? And this graph is similar to y is equal to 1 upon x. That is something like this. Okay, and when x is equal to 0, y is equal to minus 1 by 3. So this is the kind of graph that I'll be getting, okay. And do you observe that all the tangents of this particular function will be like this. This will have slope which is less than 0. Slope, negative slope, basically that's what you can observe, right? That's what you can observe over here. Is that okay? Yes, that's all in this question for us. Let's discuss this question 12th next. Question 12 says find the equations of all lines having slope 0 which are tangent to the curve this. This time the slope is given to be 0 for the tangent and curve is given y is equal to 1 over x square minus 2x plus 3. So let's begin with this. Y is equal to 1 over x square minus 2x plus 3 and let's find the derivative of this. Dy by dx will be equal to what? This will be equal to, since this is 1 upon some function, this is the derivative is minus 1 upon that function square, okay, and times the derivative of this which is 2x minus 2, okay. This is what I'll be getting, okay. This is the derivative and then the person further says that find the equations of all lines having slope 0, okay, which are tangents to the curve. So equating this slope to be 0, we get the point, that is value of x first and then the corresponding value of y. So therefore minus of 2x minus 2 over this x square minus 2x plus 3 and its square is equal to 0. On equating this equal to 0, you get 2x is equal to 2. This whole thing will go over there. This becomes 0. Therefore, 2x equals 2 or x equals 1. With the help of this, I can easily get the point. I already have the slope. I can get the point easily. X equal to 1 implies y equals 1 over 1 square minus 2 times 1 plus 3. What is that? 3 minus 2 is 1 plus 1 is 2. This is 1 upon 2. The value of y comes out to be 1 upon 2. Therefore, point is point is 1 comma 1 by 2. The point at which you draw the tangent is this. Okay. What about the slope? Slope is 0. Okay. The slope is 0. Therefore, equation of tangent will be what? Y minus 1 by 2 is equal to 0 times x minus 1. This goes and this will give me y is equal to 1 by 2 as my answer. This is the required answer for this question over here. The question 13 says find points on the curve x square by 9 plus y square by 16 equals to 1 at which tangents are parallel to the x-axis, parallel to the y-axis. There are two parts of this question, and frankly speaking, if you can easily draw the graph of this equation, this represents an ellipse, right, where the minor axis endpoints are on the x-axis and those are plus minus 3 comma 0, and major axis endpoints are 0 comma plus minus 4. What you'll get is this kind of a vertical ellipse. This is what I'll be getting, and please note this point is 3, this point is minus 3, this point is 4, this is minus 4. Okay, this is x-axis, this is y-axis. Once you are through with this, what we are doing is we are trying to solve the question orally over here, right? So find points on the curve this at which tangents are parallel to the x-axis. This will be pretty simple. Tangents are parallel to the x-axis at this point. This is 0 comma 4, and similarly 0 comma minus 4 will be another point at which tangent is parallel to the x-axis. What about tangents parallel to the y-axis? These will be the tangents parallel to the y-axis. This is the case of ellipse, and for ellipse tangents parallel to the x-axis and y-axis are very, very simple, right? But then this is using graphical approach. What can we do for this question where we have to solve it analytically, let's see. So in that case, let's try to solve finding the derivative first of all for this equation. We have x square by 9 plus y square by 16 is equal to 1. Can you differentiate this? Yes, differentiate. 2x over 9, differentiating with respect to x. The derivative of x square is 2x. The derivative of y square is 2y times, since we are differentiating with respect to x, this is what you get. Derivative of 1 is simply 0. On basis of this, I can get the value of dy by dx. This gives me dy by dx is equal to what? Minus 2x by 9 upon 2y by 16. 2y by 16, and this tells me dy by dx will be equal to what? Please note that dy by this 2 will get cancelled with this 2. This is minus 16x over 9y. This is what I'll get. Okay. On basis of this, can you solve the first and second part as given over here? We are supposed to find tangents which are parallel to the x-axis. Let's solve the first part over here. For tangents parallel to the x-axis, the slope of tangent will be 0. dy by dx equals 0 implies what? This implies that minus 16x over 9y will be 0, which gives me x will be 0. Okay. Once you get the value of x as 0, tangents parallel to x-axis, x equals to 0, implies what will be the value of y from the original equation of the ellipse, right? From the original equation of the curve, let's find y. Therefore, 0 plus y square by 16 is equal to 1. This gives me y square equal to 16, or y equals plus or minus 4. And therefore, the points, these are the required points. Can you observe? 0 comma 4, 0 comma minus 4 are the required points at which tangents are parallel to the x-axis, right? 0 comma 4, 0 comma minus 4, these will be 2 points. Let's solve part 2 then. Part 2 says tangents parallel to the y-axis. Now, if tangent is parallel to the y-axis, the normal, which is perpendicular to the tangent, will be parallel to what? The normal will be parallel to the x-axis. Tangent parallel to y-axis implies normal parallel to x-axis. Okay, that's pretty simple. If normal is parallel to the x-axis, therefore the slope of normal will be 0. Implies minus 1 upon that derivative, minus 1 upon this dy by dx, which is minus 16x upon 9y is equal to 0. This gives me simply 9y upon 16x is equal to 0, which further tells me that y equals 0. Okay, if you get y equals 0, can you also find the value of x with the help of the equation of curve? Yes. Therefore, x square by 9 plus 0 is equal to 1 over here, right? This is equal to 1. Okay, and this tells me x equals plus or minus 3. The 2 points at which tangent is parallel to the y-axis, tangent is parallel to the y-axis will be 3 comma 0 minus 3 comma 0. These will be the 2 points at which tangents are parallel to the y-axis. That's what we have over here, and that's all in this question, as you can see. Question number 14th says, find the equations of the tangent and normal to the given curves at the indicated points. Okay, this question is pretty interesting, has many parts for that matter, and we are supposed to find the equations of tangent and normal to this curve at this particular point in this case. Right. So for finding the equation of tangents and normals, we are supposed to begin with finding the derivative of this point, right? That's what we'll do. We have y equals x power 4 minus 6x power 3 plus 13x square minus 10x plus 5 at 0, 5. This is what we are interested in. Let's find the derivative. dy by dx. We already know the point, right? Finding the derivative will give us the slope of the tangent, and therefore we can get the equation very easily. dy by dx will be equal to 4x power 3 minus 18x square plus 26x minus 10. This is dy by dx. So let's find at 0, 5. At x equals 0, dy by dx will be equal to what? For x equal to 0, dy by dx will be 0 minus 0 plus 0 minus 10, which is actually minus 10. That's the slope of tangent. Therefore, for tangent, we needed two things. What are the two things? For finding equation of any line, we need two things. Tangent is also a line. We need two things, that is maybe 2 points or a point and a slope, and we have obtained that. 0, 5 is the point and minus 10 is the slope. That's what we have, right? This is the point and this is the slope. On the basis of these two, I can easily find the equation. The equation will be y minus y1 is equal to slope, that is minus 10 times x minus 0. This gives me y minus 5 is equal to minus 10x, or that tells me 10x plus y minus 5 is equal to 0 is this tangent for me. Is that okay? Yes. This is the equation of tangent, as you can see over here. What about the equation of normal? For the normal, the point is already known. The slope can easily be found by taking the negative reciprocal of this. The tangent and the normal are perpendicular to each other. If this slope is m1, this slope is m2, then you know that m2 will be equal to minus 1 upon m1. The product of the slopes is minus 1 if the two lines are perpendicular. That's what you know. So on the basis of this, I can easily comment for normal. For normal, what do I know? I know the point. This is the same point, 0, 5. And I know the slope. Slope is minus 1 upon that slope, which is minus 10. What does that give me? 1 upon 10. This is the slope. Equation will therefore be obtained very easily. Y minus 5 is equal to slope times x minus 0. That's what I'm doing over here. And this will give me 10y minus 50 is equal to x, or that tells me x minus 10y plus 50 is equal to 0. That's the equation of normal that you require for this question over here, and that's all in this question. Second part of this 14th question says that we are given a curve which is, as you can observe, the curve is similar but the point is different over here. Okay, and we are supposed to find the equation of normal and tangent. Let's begin with finding the derivative. Dy over dx is equal to what? 4x power 3 minus 18x power 2 plus 26x minus 10 is what I have. And we are given point 1, 3. Therefore, at x equal to 1, what will be the value of dy by dx? Dy by dx is equal to 4 times 1 power 3 minus 18 times 1 square plus 26 times 1 minus 10. This is 4, which is okay, very simple. This is minus 18 plus 26 minus 10. This is 30 minus 28, which is simply 2. Now that is the slope of derivative, slope of tangent basically. This is the derivative at x equal to 1, therefore this. So for tangent, what do we know? For tangent, we know two things. What are those? Point 1, 3 is known and the slope is known. Slope is 2. Okay. Equation of tangent or equation of any line passing through x1, y1 and having slope m is nothing but y minus y1 is equal to m times x minus x1. I hope you remember this, right? Okay. And if you remember this well, then you can easily find the equation of tangent over here. What is that? Y minus 3 is equal to 2 times x minus 1. Y minus y1 is equal to m times x minus x1. That's what we are doing. This is 2x that come, take the y on the right hand side. This becomes 2x minus y minus 2 plus 3. 3 minus 2 will be 1. This is equal to 0. This is equal to 0. Is that okay? Yes. That's for tangent. What about for normal? For normal, we remember that if two lines are perpendicular, this is m1, the slope is m1, this is slope m2, then the product of slopes will be equal to minus 1. That is something that we remember. So the slope of normal will be negative reciprocal of the slope of tangent, okay, or the negative reciprocal of this. So for normal, what do we have? For normal, the point is same. Point is 1 comma 3. Slope is equal to minus 1 upon that dy by dx, which is 2. That's what we have. Therefore, equation becomes y minus 3 is equal to, using the same idea, slope times x minus 1. Okay. 2y minus 6 is equal to minus x plus 1. This is what you get. And simplifying, x plus 2y minus 7 is equal to 0 is my answer for this question over here. That's a complete solution for this second part. Let's discuss the third part next. Y is equal to x power 3 at 1 comma 1. Now y is equal to x power 3 is a pretty simple equation and we can easily find the derivative of this. Dy by dx is equal to 3x power 2. And if you want to find at x equal to 1, dy by dx will be equal to what? This will be equal to simply 3. 3 times 1 square is 3. Now the equation of tangent is pretty simple. For tangent, you have two things. What are the two things? You have point. Point is 1 comma 1. You have the slope. Slope, which is m, is equal to 3. Okay. And if you have point and slope, point x1 comma y1 and slope m, you can easily find the equation of line, which is y minus y1 is equal to m times x minus x1. This is how you find the equation of line, right? A pretty simple thing. Yes. So with the help of this, I can write y minus 1 is equal to m times x minus 1. This is what we have. What does that give me? This is 3x minus y minus 2 is equal to 0. That's my final answer for the equation of tangent. What about equation of normal? We can easily find normal as well. For normal, the slope will be negative reciprocal of the slope of tangent, right? Point is same, 1 comma 1. Slope is negative reciprocal. Reciprocal of this is what you get, right? Slope is known. Y minus 1 is equal to minus 1 upon 3. X minus 1 is what I get. This becomes 3y minus 3 is equal to minus x plus 1. Is that okay? Yes. This further becomes x plus 3y minus 4 is equal to 0. This is the equation of normal, as you can see over here. That's part third for you. Part fourth says y equals to x square at 0 comma 0. We're supposed to find equation of normal and tangent. Now this y is equal to x square at 0 comma 0. This is a parabola, the standard parabola, and at 0 comma 0 the curve will be this. And can you easily find the equation of tangent and normal without doing any calculations? Maybe yes. At 0 comma 0, this is the curve y is equal to x square. So normal and tangent can be found easily. Do you observe that at 0 comma 0 this x axis is the tangent. Tangent is x axis and the equation of this x axis is simply y equals 0. And what about the normal? Normal is the line perpendicular to this tangent at this particular point, which is the y axis. And the equation of y axis is nothing but x equal to 0. This is the equation of normal. Now this is something which we can note directly from the graph, but what about calculations? Let's do some calculations and prove that yes, this is the case. Let's follow the analytical approach, although we can observe this thing directly from here as well. But if we want to solve analytically, how do we do that? Let's take a look at this. Dy by dx is equal to 2x. X equal to 0 implies dy by dx will be simply equal to 0. Pretty simple, yes. Okay. So equation of tangent. For tangent, things will not be very difficult. For tangent, you can say that y minus 0, the point is known, is equal to 0 times x minus 0 is what I get. This tells me y equals 0 is the equation of tangent. The equation of tangent is simply y equals 0, and this is the x-axis basically. For normal, what do we do? For normal, you note that y minus 0 will be negative reciprocal of this 0. Oh, but you don't divide by 0. Don't worry about that too much. You don't divide by 0, but I can multiply by 0 over here, right or not? Yes. So, what I can do is, we don't divide by 0, that's okay. But can we actually multiply by 0 without affecting anything too much? Yes. Maybe y minus 0 will be equal to something times x minus 0 minus 1 upon that slope of tangent. What is that? That's simply 0. I can do that, yes. And this tells me that x equal to 0 is the equation of normal, as you can see over here as well as over here using this approach. The only thing that will be an issue will be this division part, and I think you can take care of that with a simple idea, right? We say that it is the negative reciprocal, but for 0 you cannot take the reciprocal, so never mind. Instead of taking the reciprocal over here, simply take the denominator on this side and you are good to go with this. That's the equation of tangent and normal for this curve over here. The fifth part says x equals cos t, y equals sin t at t equals to pi by 4. Okay. The equation of curve is given in terms of parameters x and y in terms of t, and at t is equal to pi by 4 we are supposed to find the equation of tangent and normal. And how do we do that? Okay. So first thing that we are supposed to do is find the slope dy by dx. Now dy by dx in terms of parameter, when the values are given, we'll have to derivative with respect to t and this dy by dt on dx by dt. What is dy by dt? Derivative of y with respect to t, sin t derivative is simply cos t. Derivative of cos t is minus sin t, okay, and this becomes minus of cot t. Is that okay? Yes. At t equal to pi by 4, what does this become? At t equals pi by 4, comma, dy by dx will be equal to what? Cot pi by 4 is 1, therefore this will be equal to minus 1. That's the first thing that you note. But do you also understand one thing over here, that do you realize that at t is equal to pi by 4, you will have to find the points as well, right? So you don't directly have the points. At t equals to pi by 4, dy by dx is equal to this. X is equal to sin pi by 4, which is 1 upon root 2, and y will be equal to cos pi by 4, which is 1 upon root 2. And now I have the 2 points. Sorry, I have the point, right? This is x comma y, 1 by root 2 comma 1 by root 2. That's the point. Okay. So for tangent, what do I need? Point is 1 by root 2 comma 1 by root 2. Okay. Slope is equal to minus 1. This is the point and this is the slope. I can easily find that equation after that. For normal, what do I need? I need again 2 things. What are those 2 things? Similar things. Again, I have the point, the same point, 1 by root 2 comma 1 by root 2, and I have the slope. Slope is negative reciprocal of this. Okay, this is minus 1. Minus 1 upon this expression is what I'll need. Minus 1 upon minus 1, which is plus 1. That's the slope of this particular normal. Now, finding that equation will not be difficult. Equation will be y minus 1 by root 2 is equal to slope times x minus x1, which is 1 upon root 2. This is what I get. Right? Minus x will come over here, and what will this give me? X plus y minus 1 by root 2, and this becomes minus 1 by root 2 again. Is it? Yes. This becomes minus 2 by root 2. This is minus root 2 will be equal to 0. That's the equation of tangent. What about equation of normal? You will write y minus 1 by root 2 is equal to x 1 times x minus 1 by root 2, and this will give me y equals x, or you can write it as x minus y is equal to 0. That's the equation of normal for this equation over here. That's a complete solution that is required. Question number 15 says, find the equation of tangent line to the curve this to the line this, which is parallel to the line this, perpendicular to the line this. Okay. So a line which is parallel to the line, you are aware of the slope. Again, a line which is perpendicular to another line, you are aware of the slope. So let's, in the first and second part, let's talk about the slope of the required tangent line first, and then we can compare with the derivative, find the points easily. Okay, find the equation of tangent line to the curve this. Okay, so the curve is y equals x square minus 2x plus 7. This tells me that y prime, which is derivative will be equal to 2x minus 2, and this will be equal to some slope. We'll get the point after that only. What is the slope? In the first part, the slope for the first part, it is given that parallel to the line this. Okay, slope of tangent will be easily slope of given line. What is the slope of given line? Now, for finding the slope of given line, you should be aware of one important concept. And what is that important concept? Ax plus by plus c equal to 0. This particular equation. For this particular equation, what is the slope? You're not aware of the slope directly, but you can find the slope using this idea over here. And how do I get that result? I'll explain that. This is minus a by b. This is the slope of this line. Okay, how do you get that? With a simple idea, you know the slope of y is equal to mx plus c, right? The slope is this m. Okay, so let's write this expression in terms of this form. What do we do? by, I'm simply deriving this. by is equal to minus ax minus c, and therefore y will be equal to minus a by bx minus c by b. If you observe this carefully, you will see that y equals something times x. That something is the slope. This is the slope, and therefore yes, m equals minus a by b. That's the slope, and we are interested in that, right? Slope of given line is minus a by b. This is given the line ax plus by plus c in the form this, right? Slope will be this, and this is equal to minus 2 over minus 1, which is simply 2. This is the required slope of tangent as well, because we are supposed to find tangent. Therefore, slope of parallel tangent, right? That's what we are interested in. For a parallel line, the slope will be same. Find the equation of tangent line to the curve this, which is parallel to the line this. Therefore, this is the slope of tangent, and on the basis of this, I can find the point easily, which gives me y prime is equal to 2. That tells me 2x minus 2 is equal to 2, or it tells me x equal to what? 2x equals 4, x equals 2. Okay, and which further tells me that y equals what? For the point, you also need y. Y will be equal to 2 square 4 minus 4 plus 7. This simply says 4 minus 4 plus 7, which gives me y equals 7. That's what you obtain. The point is known, the slope is known. For the tangent, equation of tangent you can find with the help of point. Point is 2 comma 7, and slope is equal to 2. For equation, you need these two things. On basis of these two things, therefore, tangent, the equation of tangent can be found with the help of these. Y minus 7 is equal to 2 times x minus 2, which tells me y equals 2x. 7 minus 4 is 3. This is what you get. This is the equation of tangent line. This is the equation of tangent line. Once you're through with the tangent line, can we solve part 2 as well? That is part B. Part B says perpendicular to the line this. If tangent is perpendicular to this line, we need the slope of this line first of all, right? Slope of given line is equal to minus a upon b. A is the coefficient of x, mind you. Coefficient of x. What is that? Minus 15. So this becomes 15 over b, which is 5. This gives me 3. If slope of given line is 3, then slope of perpendicular tangent will be equal to what? Slope of perpendicular tangent. Now tangent is perpendicular to this, therefore slope will be negative reciprocal of this. Minus 1 upon this, which is minus 1 upon 3. Okay. And what about the point on the curve? Can we find the point on the curve? Yes. This is equal to y prime. Okay. Therefore, 2x minus 2 is equal to minus 1 by 3. This tells me 2x will be equal to 2 minus 1 upon 3, which is 5 by 3 upon 2. X will be equal to 5 by 6. Very interesting. X equals 5 by 6, and what will that imply? Y equals what? Y can be found with the help of this over here. This is 5 by 6 whole square, which is 25 upon 36, minus 2 into 5 by 6, which is actually 5 by 3, plus 7. Okay. And what does this become equal to? Let's add them. Let's take the LCM. 26 and 3, the LCM is 36. So 36 and 3, the LCM is 36 only. What about the numerator? In the numerator, you have 25 minus 60. Is that? Yes. A big, huge number in the numerator. Okay. 25 minus 60 is minus 35. And then minus 35 plus 7 times 36. Now 7 times 36 will be big. What is that? 7 times 36. 14 times 18 is 16 square minus 4 is what I will get. This is 252, right? 16 square minus 4 will be this, right? 252, and 252 minus 35. 252 minus 35 will be 217 actually. This is 217. Right? I hope we are correct. This 217 upon 36. Let's check that value once again. So 36, 3 and 1, the LCM will be 36 in the denominator. Okay, in the denominator you have 36. What about the numerator? In the numerator you have 25 minus 60 plus 7 times 36. 7, 6, 42, 2 and you carry forward a 4, 21, 25, 252. We took that correct. 252 and 252 minus this. 277 minus 60 is 217, right? 217 upon 36, that's what you have. Okay, so y is 217 upon 36, that's known, x is known, therefore the point is known. Therefore, for equation you need the point and the slope, and you are aware of point which is 5 by 6 comma 217 over 36, and you are also aware of the slope which is minus 1 by 3. This is minus 1 upon 3. Okay, and on the basis of these two things, can you find the equation easily? Yes, you can easily find the equation. How do we do that? Y minus y1 is equal to m times x minus x1. Let's substitute the values over here. And what do we get? We get, okay, this will become y minus y1, which is 217 upon 36. This is what you get. Y minus y1 is equal to slope minus 1 upon 3 times x minus this x1, which is 5 by 6. Okay. Observe that there will be a 6x minus 5 over there. 6 times 3 is 18 in the denominator. On the right hand side, there's 36 over here. Let's multiply throughout by 36. That will be simple, yes. So what we'll get is 36y minus 217 is equal to what? This 36 upon 3 with a minus, which is 12. With a minus, this becomes minus 12x and minus 12 into minus 5 by 6. What is that? Plus 10. This is plus 10 is what I get, and therefore 36y plus 12x minus 227 is my answer. The final answer will be, let me write the final answer over here only. This tells me 36y minus 12x, 36y minus 12, sorry, plus 12x, and what else? Minus 227 is equal to 0. That here is the final answer of this one. Let us write this properly. This is 12x. 36y plus 12x minus 227 equal to 0 is the equation of normal, as you can see behind us, is the equation of tangent which is perpendicular to the line this. That's the final answer for this second part. The first part is this. That's a complete solution of this question. The 16th question says, show that the tangents to the curve this at the points where x equal to 2 and x equal to minus 2 are parallel. Okay. Tangents at x equal to 2 and x equal to minus 2 are parallel implies that the slope, that is the derivative, will be same for these two lines. So y equals 7x power 3 implies plus 11, okay, dy by dx, that is y prime is equal to 21x square plus 0, okay, and for x equal to 2, x equal to minus 2, what are the slopes? X equal to 2 implies y prime is equal to 21 times 2 square, what is that? 4 times 21? Yes, what is that? 84. X equals to minus 2, what does that imply? This implies y prime will be equal to 21 times minus 2 square. And what is that equal to? This is 4 times 21, which is 84. Since they are exactly same, implies, since the derivatives are same, therefore the slopes of tangents are same. Tangents are equal. Okay, and if slopes are equal, therefore the lines are parallel. That's the complete proof of this question over here. The 17th question says, find the points on the curve this at which the slope of the tangent is equal to the y coordinate of the point. Okay, pretty interesting. Points on the curve this. Y equal to x power 3 is the curve. And we are supposed to find the point on this. Slope of the tangent is equal to y coordinate of that point. Okay, let h comma k is the required point. Okay, this is what we have. What about y prime? Y prime is equal to 3x square. Okay, so it is given that slope is equal to the y coordinate of this point. Y prime is equal to k. Y prime at h comma k is equal to k. This is the condition that I'll apply, right? So y prime at h comma k will be 3h square, and this is equal to k. This is what the person has given to us, right? Is there any relation between h and k? Yes. If this is a required point, then k will be equal to h power 3. That is what I know from the equation of curve, right? So there are actually two equations and two unknowns. H and k are the two unknowns, and yes, there are two equations between h and k, right? Slope of tangent is equal to this y coordinate of the point. From equation 1 and equation 2, can I eliminate k easily? Yes. Therefore, h power 3 is equal to 3h square, which tells me h square is equal to 0 or h equals 3, right? This is what I have done is I have simply arranged this h minus 3 is equal to 0. Brought this here and taken h square common. So either h square will be 0 or the other factor h minus 3 will be equal to 0. This tells me h equals 0 or h equals 3. But are these the points? No, these are only the x coordinates of the points. Let's find the y coordinates as well. K will be equal to what? K will be simply h power 3, which is 0. And here k will be equal to h power 3, which is 3 power 3. 3 power 3 will be 27. This what gives me. Therefore, points 0, 0, h, k and 3, 27. 3, 27 is what I get. These are the 2 points at which the slope of the tangent is equal to the y coordinate of the point. That's what we have in this question. Let's move on to the next one. Question 18th says, for the curve y is equal to 4x power 3 minus 2x power 5, find all the points at which the tangent passes through the origin. Okay, for the curve this, find all the points at which the tangent passes through the origin. Okay, let's take a look at this. Y equals 4x power 3 minus 2x power 5, and let us take any point on this curve first of all. Okay, so that tangent passes through the origin. That is something which is interesting. Let's say that let h comma k be the required point on curve. Okay, this is the point on the curve which is required, and what is the condition given on this point? For this curve, find all the points at which the tangent passes through the origin. So at this point, the tangent passes through the origin. That is a condition, right? So if h comma k lies on this point, one thing that I know for sure is k equals to 4h power 3 minus 2h power 5. This is something that I know. Okay, this point lies on this curve, therefore this point will satisfy this curve. What else? Let's try to find the equation of tangent. So for that I need the derivative. Y prime will be equal to 12 x power 2 minus 10 x power 4. Okay, and the derivative at h comma k will be equal to y prime for x equal to h will be equal to 12 times h square minus 10 times h power 4. But we are not only interested in this derivative, we are interested in further. This derivative will give us the equation of tangent at h comma k. So equation of tangent, what is that? Y minus y1 is equal to slope 12 h square minus 10 h power 4 times x minus x1, which is this. This is the equation of tangent. Okay, and there's another condition given on this tangent, that this tangent passes through origin. Zero comma 0. So x and y can be replaced by 0 comma 0. This gives me 0 minus k, okay, is equal to 12 h square minus 10 h power 4 times 0 minus h. Okay, once you are aware of this, you can see that there is another relation between h and k. There's one relation already over here. This is the first one and this is the second one maybe. We can use the first one and the second one, yes. The value of k can be substituted from here to here and we'll get a single equation in terms of h. From there I will get h, right? Yes. So minus this, minus 4h power 3 plus 2h power 5 is equal to what? This is minus h, minus 12h power 3 plus 10h power 5 is what I get. Let's rearrange. Minus 12h cube comes over here, this becomes 8h power 3, this 2 goes over there, this becomes 8h power 5. Okay, the factor of 8 gets cancelled, h power 3 comes out, when you go take it over there, what remains is h square minus 1 equals 0. Take it on the right hand side, right? And this is what you get. This tells me h power 3 is equal to 0 or h square is equal to 1, which further tells me h equals 0 or h equals 1 or h equals minus 1. Okay, h square equal to 1 will tell me that h equals to 1 or h equals to minus 1. This is one possible point, this is another point, this is the third point. But the point is completely known when you also have the y coordinate. For y coordinate I can use equation 1, right? Therefore, k is equal to, for 0, this is 0 minus 0. K equals, for 1, this is 4 minus 2, which is 2. For minus 1, this gives me k equals minus 4 plus 2, which is minus 2. Okay. Therefore, points. What are the points? At the end of the day, you need the points, right? For the curve this, find all the points at which the tangent passes through the origin. So, one of the points is 0, 0, the other point is 1, 2, the third point is minus 1, minus 2. Let's write those points. Required points 0, 0, 1, 2 and minus 1, minus 2 are the required points, and that is the complete solution of this question. Question number 19 says, find the points on the curve this at which the tangents are parallel to the x-axis. Tangents parallel to the x-axis, therefore slope will be 0, and we can solve for that. That's not very difficult. So you have x square plus y square minus 2x minus 3 is equal to 0. Differentiate with respect to x. X. What does that give me? That tells me that 2x plus 2y, y prime minus 2 will be 0. What does that give me? This tells me that y prime will be equal to what? This is 2 minus 2x over 2y. This is what it tells me, right? Is that simple? Yes. And points on the curve at which the tangent parallel to the x-axis, the tangents parallel to x-axis implies slope will be 0. If tangents are parallel to the x-axis, slopes will be 0, which implies y prime will be 0, and this further tells me 2 minus 2x over 2y for this equation will be 0. Where does that take us? This will imply that 2 minus 2x is equal to 0, which gives me x equals 1. This is what it tells me, right? If x equals 1, what is the value of y? Yes, you will get the points on the basis of that, right? So therefore, 1 square plus y square minus 2 times 1 minus 3 is equal to 0. What is that? Y square minus 5 plus 1 is minus 4 is equal to 0. This tells me y equals plus or minus 2. Okay, x equals 1, y is equal to plus minus 2. Therefore, points 1, 2 and 1, minus 2 are the required points for this one over here. Let's discuss question number 20th. What does the question say? Find the equation of the normal at point this for the curve this. Okay, pretty interesting. A y square is equal to x power 3, and you are interested in the equation of normal at the point am square am power 3. Can you easily find the derivative? Yes, we can easily do that. A times 2y, y prime is equal to 3x power 2. By differentiating with respect to x, this is what you get. Y prime is equal to 3x square over 2ay. Okay, this is the derivative that will give me the slope of tangent. What is the slope of normal? Slope of normal will be this, negative reciprocal of this. Slope of normal at am square comma a m power 3 is equal to minus 1 upon this y prime at x at the point this, at the required point, right? We can simply say at the required point. That's not an issue. This is equal to minus 1 upon, what is this? 3x square. So this becomes 3 times am square and its square. In the denominator you had 2ay, which will go over here in the numerator. This becomes 2 times a times y, which is am power 3. This is what you will get, right? And from here the slope will be equal to what? This is minus 2a square m power 3 upon 3a square m power 4, which is equal to what? This is 2 by 3, a square goes, m power 3 also goes, this is minus 2 upon 3m. This is what you get. This is the slope of normal. You already have the point, therefore equation of normal is not very difficult. Y minus y1 is equal to slope times x minus x1, what is that? am square. And let's rearrange this to get the required equation. Let's rearrange this. Yes. This tells me, let's multiply by 3m, 3my minus a into 3 m power 4 is equal to minus 2x plus 2a m square. Okay, and on rearranging further, this is 2x plus 3my is equal to 2a m square plus 3a m power 4. This is what I will be getting finally, and that's the required answer for this question over here. Let's discuss question number 21 next. Find the equation of normals to the curve this which are parallel to the line this. Okay, normals which are parallel to this. So slope of normal, that is something which you are aware of. Equation of normals are supposed to be found for this. So for equation of normals I need the slope of normals as well as the points, right? So yes, parallel to the line this, slope of normal will be equal to what? Is equal to slope of x plus 14 y plus 4 is equal to 0. This is what we have, right? And what is this line equal to? Can you rearrange this? This is 14y is equal to minus x minus 4, which gives me y equals minus 1 upon 14x plus, minus 4 upon 14. Minus 4 upon 14. And from here, yes, it is very easy to identify the slope. You could have directly done minus a by b, or this. This is telling me that the slope is equal to minus 1 by 14 for this one. Okay, and on the basis of this idea over here, slope of normal is actually minus 1 by 14. This is what I am aware of now. Okay, slope of normal, once it is known, can I find the points with the help of this? Yes. First, with the help of slope of normal, find the slope of tangent. Is equal to negative reciprocal, minus 1 upon minus 1 by 14. What is that? 14. Negative reciprocal, this is, since the two are perpendicular, this is what you'll have. Slope of tangent is simply 14. Okay. Once you have slope of tangent as 14, equation of normals to the curve this which are parallel to the line this, can we find the points as well? We already have the slope, right? Let's try to find the points. For that, I'll have to differentiate this given equation. Y equals x power 3 plus 2x plus 6 gives me y prime is equal to 3x square plus 2. This is what it tells me, right? Y prime is equal to 3x square plus 2. And y prime is equal to 14. Since y prime is equal to 14, that tells me 3x square plus 2 is equal to 14, which further tells me x square is equal to 12 by 3, 4, or x equals 2, x equals minus 2. The values of x will be 2 or minus 2. Those are the two possible values of x. X equal 2 implies what? Y equals what? The point x equal to 2 will tell me that y will be equal to 2 power 3 plus 2 into 2 plus 6. That's what you'll get. 2 power 3 is 8 plus 4 is 12 plus 6 is 18. This tells me that y equals 18. This tells me that this equals 18. Or the other point is x equals minus 2, which implies y equals what? Using this equation, once again, what you'll get is minus 8 minus 4, which is minus 12, plus 6 is minus 6. This tells me y equals minus 6. Okay, so the point is 2 comma 18, and here the point is minus 2 comma minus 6, but that's only one information. The other information is the slope. Slope of normal is minus 1 by 14, and the same slope here as well. With the help of these two ideas, can you find the equations of normal? Yes, equation of normals. With the help of this idea over here, I can easily get the equations of normals. What do we have? Y minus 18, y minus y1 is equal to slope times x minus x1, which is 2. And where does that take us? This is 14y minus 18 times 14. It is 16 plus 2, 16 minus 2, which is 16 square minus 2 square, 256 minus 4, which is 252. Okay, this is minus x plus, okay, this is minus x plus 2. Please note this, minus x plus 2 is what you'll get, and rearranging will tell me x plus 14y. X plus 14y is equal to 254. This is what I'll be getting. That is one of the normals, mind you. The other normal will be obtained with the help of this. This is y minus y1 will become y plus 6 is equal to slope times x minus x1, which will become x plus 2. Let's multiply them together. This is 14y plus 6 times 14. What is that? 84, and mine is equal to minus x minus 2. This will further tell me x plus 14y plus 86 is equal to 0. That's the other normal. As you can see, the complete solution behind me over here. Question number 22 says, find the equations of the tangent and normal to the parabola this at the point this. We are supposed to find the equations of tangent and normal. By the way, if you have studied conic sections properly, you would have found the equations of normal and tangent at these points. Now, what are the equations of tangents and normals? You should remember. We'll find them and you will remember them. Okay, find the equations of tangent and normal to the parabola this at the point 80 square comma 280. One of them is ty is equal to x plus 80 square. The other one, we remember preferably in terms of the slope, the equation of normal is y is equal to mx minus 2m minus am power 3. But you replaced m by minus t. What do you get? Y is equal to minus tx plus 280 plus 80 cube, and that is your equation of normal. Let's derive those two things over here in terms of this parametric coordinate t for this standard parabola. So find the equations of tangent and normal to this. We begin with y square is equal to 4ax. And the point is 80 square comma 280. The first thing that I'm going to do is find the find the slope of tangent by differentiating. 2y, y prime is equal to 4a. This tells me y prime will be equal to 4a upon 2y, which tells me that y prime at 80 square comma 280, which is the required slope. Let's write it in the next line. This y prime, which is the required slope, will be equal to what? Therefore, y prime at 80 square comma 280 will be equal to 2a upon y, which is 280. This is 1 upon t. Please note that this is 1 upon t. So this is the slope of tangent. Yes. So for tangent, what do we know? We know the point is 80 square comma 280. And we know the slope, which is 1 upon t. This is what we have. Equation is not difficult. For the tangent, the equation will be y minus y1 is equal to slope times x minus x1. This is what we have, right? Let's multiply this t and see ty minus 2at square is equal to x minus at square. This further tells me ty is equal to x plus at square, and a very, very important equation from the chapter conic sections. Once again, this is equation of tangent for this parabola at this parametric point 80 square comma 280. This is something which you can remember. This is derivative, which gives me slope of normal very easily over here as well. Slope of normal will be equal to minus 1 upon y prime. What is that? This is negative reciprocal of this. Take the reciprocal and multiply with the minus. this becomes minus t, and that is the required slope of normal. So for normal, what are the two things that you need? We need point, which is again 80 square comma 280, and we need the slope, which is minus t, as you can see over there. Yes, equation of the normal is very simple after that. Y minus y1 is equal to slope times x minus x1 80 square. And let's rearrange this. This is y minus 280 is equal to minus of tx plus at power 3. This becomes y is equal to minus of tx plus 2at plus at power 3. This is what you get, and that's a required equation of normal for this standard parabola at this parametric point. That's the final answer for this question. You can remember these two equations for solving questions in the JEE examinations directly on the basis of this. Question number 23 says, prove that the curves x equals y square and xy equal to k cut at right angles. Now, right angles is something which is explained, given as a hint and star mark in the NCERT textbooks as well. If 8a square is equal to 1. Now, what do you mean by right angles? It simply means that at the points of intersection, for example, if you have two curves intersecting at some point P, then the tangent to the first curve and the tangent to the second curve at the point P must be at right angles. That's the meaning of intersection at right angles, cut at right angles, right? These are also called orthogonal. Cutting at right angles will also be orthogonal curves. Although orthogonal is a much more wider definition, orthogonal has a much more wider definition, which says that at all points of intersection, the angle should be 90 degree. Between the curves, at all points of intersection, the angle should be 90 degree. That's the idea behind orthogonality, right? If two curves intersect at more than one point, then at all points, the angle between the curves or the curve should cut at right angles for them to be orthogonal. That's the idea behind this. Now, let's approach this question and see where does that take us. Prove that the curves this x equals y square and xy is equal to k cut at right angles if 8k square is equal to 1. Okay, so we are interested in k is already used. Let's pick up some point of intersection. Let's say they intersect at some point alpha comma beta. If these two curves intersect at alpha comma beta, then we can simply say that we'll find a relation between alpha and beta easily. First of all, yes, let alpha comma beta is point of intersection. Okay, therefore beta square, that is y square, alpha will be equal to y square, right? X is alpha, y is beta square, y is beta, and the other thing is alpha beta, the product is equal to k. Those are two things that I know. This is first equation, this is the second equation. Okay, and we have to prove that these intersect at right angles. So for that, we'll have to find the slope. Find the slope, that is the derivative at this point alpha comma beta. Differentiating the first one x is equal to y square will tell me differentiate with respect to x. This will tell me 1 equals 2y y prime, which gives me y prime is equal to 1 upon 2y. Okay, and this further tells me y prime will be equal to this slope will be equal to 1 upon 2 beta. Okay, the other equation for the second equation B, you have xy is equal to k. Differentiate with respect to x. What do we do that? How do we do that? We simply say that x times derivative of y, which is y prime, plus y times derivative of x, which is 1, is equal to derivative of k, which is 0. This is what you get. This tells me y prime is equal to minus y over x. This tells me this. And on the basis of this, I can say that y prime at alpha comma beta will be equal to minus beta upon alpha. Okay, this is known. Now, if these two curves intersect at right angles, then this first slope, this second slope, the product m1 and m2 should be equal to minus 1. Yes. That is something which we should be aware of, which we are aware of, right? So therefore, m1, m2 is equal to minus 1 implies that 1 upon 2 beta times minus beta over alpha is equal to minus 1. Where does that take us? Minus gets cancelled, beta gets cancelled. 1 upon 2 alpha is equal to 1 or 2 alpha is equal to 1 is what I get. But is this the required condition? No, this is not the required condition. The required condition is in terms of k. Okay. If these curves intersect at right angle, then this. Cut at right angles if this. Okay. So let's try to find alpha maybe in terms of k and we'll be able to get the answer, right? So what do we have? We have alpha beta is equal to k. We have alpha is equal to beta square. What do we need to do? We need to eliminate beta and get a relation between alpha and k. With the help of that, I can get alpha in terms of k, right? Let's do that over here. What do we have? This is beta is equal to k upon alpha. Therefore, alpha is equal to beta, which is k square over alpha square, which tells me that, yes, beta is k upon alpha. So, alpha will be equal to beta square, which is simply equal to k square upon alpha square. And this further tells me alpha power 3 will be equal to k square. Is that okay? Yes. This tells me alpha power 3 is equal to k square. Okay. And can we substitute alpha over there? Yes, we can substitute alpha over there easily. Next, how do we eliminate this alpha from these two equations? It's pretty simple, not a difficult thing to do. We have alpha cube is equal to k square, and on the basis of this, I can substitute it here. But first, let's tune this, right? 2 alpha whole cube will be equal to 8 alpha power 3, which is equal to 1 power 3, which is 1. What is alpha power 3? This is k square. So this tells me, yes, 8k square will be equal to 1 when the curves intersect at right angles. This implies this. Therefore, yes, this implies this and this implies this. Both are correct, and that's a complete solution of this question over here. This is a required condition. Yes. Question number 24 says, find the equations of the tangent and normal to the hyperbola this at the point x naught comma y naught. Okay. Equations of the tangent and normal. Let's see. To the hyperbola this at the point this. Okay. So we have x square over a square minus y square over b square is equal to 1. Okay. At x naught comma y naught is what we are interested in. Okay, but these are also standard results, right? The equation of tangent at this particular point will be x naught upon a square minus y naught upon b square is equal to 1. Let's try to prove that over here and we'll remember the results as well, right? So for finding the equation of normal and tangent, we'll have to use the derivative, right? So let's differentiate. This gives me differentiating with respect to x, 2x over a square minus 2y, y prime over b square is equal to 1. This is what we are interested in, right? Okay. And what else? This is equal to 0, by the way, right? So from here, what I'll observe is y prime is equal to what? This will come on the right hand side, this will remain on the left hand side. 2's will get cancelled, that's what you can observe. And b square x upon a square y will is what I'll get. B square x over a square y. This is the derivative. This will tell me the slope of tangent, right? So with the help of this, I can easily write the equation of tangent. For tangent, what do we know? We know that the point is x naught comma y naught. We know that the slope is b square x naught over a square y naught. And with the help of this, I can write the equation very easily. Equation of tangent will be equal to what? Y minus y naught will be equal to b square x naught over a square y naught times x minus x naught. This is what you have. Let's rearrange this whole thing somehow, and what do we get? What I'll do is x naught by a square, let it remain over here, and what I'll do is I'll multiply throughout with y naught upon b square. Y naught upon b square. That's what we'll be doing. So this becomes y naught over b square minus y naught square over b square is equal to x naught over a square minus x naught square over a square. And what's the benefit of this? Let's see. The benefit of this is that since x naught comma y naught lies on this point, therefore we know that x naught square over a square minus y naught square over b square is equal to 1. Do we remember this? Yes. We know this, yes. And do you observe that this, when it comes over here, this x naught square upon a square minus y naught square upon b square will be simply equal to 1. So take this on that side. What will that be? X naught over a square minus y naught y naught over b square will be equal to this minus this will be equal to x naught square upon a square minus y naught square upon b square, which is equal to 1. So therefore this is equal to 1. This is the equation of tangent. That's the first part of this complete question. That's the first part of this question. Okay. What about the second part? The second part says that the equation of normal is supposed to be found. For finding the equation of normal, we have the point. For normal, again, we have the point x naught comma y naught. And we have the slope, which is the negative reciprocal of this. Negative reciprocal of this, take the reciprocal, a square y naught over b square x naught with a minus. This is the slope of normal. Okay. Once you're through with this, then you can easily find the equation of normal. Yes, let's try to find the equation of normal with the help of this. Y minus y naught, this is the equation, is equal to the slope minus a square y naught upon b square x naught times x minus x naught. This is what you have, right? Okay. And what else? So let this a square and x naught remain with this, because a square and x are with x only. And let's take that y naught and b square over here. Let's multiply by b square upon y naught. So this becomes b square y upon y naught minus b square y naught upon y naught. This is what you get. Okay. And this here is a square upon x naught with a minus a square x over x naught and plus a square x naught upon x naught is what I get. Okay. Let's rearrange a bit. Let's bring this a square term over here. A square x over x naught plus b square y over y naught is equal to this plus this. And what is that? This y naught goes, this x naught goes, this is simply a square, and this here is plus b square. That is the required equation of normal. That is the required equation of normal. You can memorize this, you can memorize this to solve questions in future examinations, competitive exams if you are appearing for those. Otherwise, for the NCERT, from the point of view of NCERT, you can learn only these derivations are important. Nothing much is important other than that. This is x naught upon a square minus y naught upon b square equal to 1. This is a square x upon x naught plus b square y upon y naught is equal to a square plus b square. That's the equation of normal to this hyperbola at the point x naught comma y naught. Question number 25 says find the equation of tangent to the curve this which is parallel to the line this. Okay. So we are supposed to find the equation of tangent. For that, we are given kind of the slope in one way. We can find the point with the help of that, and therefore we can find the equation easily. How do we do that? For y equals under root of 3x minus 2. This is the equation of curve. Y prime will be equal to 1 upon 2 under root of 3x minus 2 and times the derivative of 3x minus 2, which is 3. This is what you get. This is 3 over 2 times under root of 3x minus 2 is what I get. Is that okay? Yes, that's pretty simple. And once you are through with this, then what next? We'll be able to gauge the slope with the help of this. Line is 4x minus 2y plus 5 is equal to 0. Slope will be simply minus a upon b, which is 2. Or you can rearrange this equation. 2y is equal to 4x plus 5 and y is equal to 2x plus 5 by 2, which will give me the slope directly. Slope is equal to 2. This is a slope which is equal to the slope of tangent. Therefore, y prime will be equal to 2, and this tells me that 3 upon 2 times under root of 3x minus 2 is equal to what? This is equal to 2. Therefore, under root of 3x minus 2 is equal to 3 upon 4, which tells me two things. One, that is y is equal to 3 upon 4. Y equals to 3 upon 4 and 3x minus 2 is equal to 9 upon 16, which tells me 3x is equal to 41 upon 16. Oh, is it? 9 upon 16 plus 2 will be 41 upon 16. That tells me x equals 41 upon 48. Okay. Y equals 3 by 4, x equals 41 by 48. We have the point. And once we have the point, we already know the slope. We can find the equation. Yes. Point is 41 upon 48, comma, 3 by 4. This is the point. Okay, slope is already known. Slope is equal to 2. Therefore, equation of normal, what will that be? Can be found easily. This is this can be obtained easily by y minus 3 by 4, y minus y1 is equal to m times x minus x1. 41 upon 48. This is the equation of normal. And what will this give us? You have a 48, you will multiply this by 2 and you will get it 24 in the denominator. Why not multiply by 24 throughout? We can multiply by 24, right? So this becomes 24y minus 18 is equal to 48x minus 41. Yes, this is what you get. Please note this. Yes. And rearranging this, what you will get is 48x minus 24y is equal to 48x minus 24y is equal to 41 minus 18. What is that? 23. This is 23. And yes, this is the required equation of normal as per these conditions. As you can see over here, what we have done is first we are given the equation. On the basis of this, we have found this, and on the basis of the line, we have found the slope. Comparing them, we have found the point over here very easily. Okay, you may make a mistakes at one point. Please note that point where children may make a mistake. That is, with the help of this, you find x equals to 41 by 48 first, and then you substitute back. And then you say, okay, under root of 3x minus 2 will be equal to under root of 9 by 16. Let me write it as plus minus 3 by 4. Now that will be wrong, and that is not something which you should do. Under root of 3x minus 2, since it is already given with a plus sign, the value will be 3 by 4 only. Don't take minus 3 by 4 over there. And that is the answer of this question, as you can see over here. Question number 26 says, the slope of the normal to the curve this at x equal to 0. Okay, we are interested in the slope of normal for y equals 2x square plus 3 sine x at x equal to 0. We are interested in this point. So let's find the derivative first. This is 4x plus 3 cos x. Putting x equal to 0 will get the derivative which will tell us the slope of tangent. What is that? Y prime will be equal to 0 plus 3 times cos 0, which is 1. This is 3. This is the slope of tangent. Implies slope of normal will be negative reciprocal of this. Minus 1 by 3 is the required answer for this question. What is that? This is option D is the correct answer for this question. Let's discuss question number 27, which says the line this is a tangent to the curve this at the point. Which point are we talking about over here? We have y square is equal to 4x and tangent is y is equal to x plus 1. Now one of the ideas, if you remember the tangent for standard parabola, what's the equation of tangent for standard parabola? Y square is equal to 4ax. At the point at square comma 2at, this is a parametric point on this curve. X equals this, y is equal to this. The equation of tangent in one of the questions we have derived as this. And comparing these two, do you observe that first of all, a is equal to 1 over here, since 4ax and a equals 1 over there, right? And the other thing is that t is also equal to 1. Okay. So point, this is the equation of tangent, and therefore point will be 1 times 1 square comma 2 times 1 times 1, which will give me 1 comma 2 should be the point of on the curve at which we are supposed to find the tangent. But this is all if you remember this. Oh, but we don't remember this. Don't worry about that. We will be able to handle without that as well. Calculations will be slightly more maybe. Let's see. We have y square is equal to 4x and this is the tangent. So do you observe that slope will be equal to 1 over here? Yes. Okay, and what is the slope? Du prime 2y, y prime is equal to 4, which gives me y prime is equal to, this is y prime, this is y prime is equal to 2 over y. Okay, comparing this y prime with that slope, we get y prime is equal to 1 implies 2 upon y is equal to 1, which gives me y equals 2. This is the y coordinate of the point. What about the x coordinate of this point? We can also find the x coordinate easily by y square is equal to 4x implies 4 is equal to 4x, which gives me x equals 1. Therefore point, the line this is a tangent to the curve at the point 1 comma 2 is the correct answer for this question, as you can see over here. This is 1, 2, and which point is this? This is option A, and that is the correct answer for this question, as you can see over here. With this, we come to the conclusion of this exercise number 6.3 based on application of derivatives. Very, very interesting concepts of tangent and normal and their equations is what we have dealt with over here. Right, till the next video, all the best.